Hello everyone and welcome back to another lecture on vector algebra. So in our previous lecture we learned what is dot or a scalar product. So in this particular video we will learn what is cross or a vector product. So this is also very important like dot or a scalar product. Now let's see what is a dot product or a scalar product. So first we have to take two vectors a bar and b bar where both are what non-zero and non-parallel. Okay, so non-parallel means they will not they are not parallel, because if they are parallel then there will be no angle between a bar and b bar. Okay, so they have to be intersect. Then the vector product, so vector product, how we denote it? A bar cross b bar is defined as, so we'll write a bar cross b bar like this. It's modulus a bar, then modulus b bar, sine theta, and then n cap. So in dot product we have modulus a bar, modulus b bar, only cos theta, n cap is not there. Okay, so here n cap is an extra thing that will understand what is n cap. The sine theta is angle between what? A bar and b bar. So suppose these are the two vector a bar and b bar. They are non-parallel vector and they lie in one plane. Okay, they suppose lie in one plane. This is O. The angle is theta. Now if we go from A to B bar, okay, this direction, anti-clockwise direction, just you think this direction means we are opening the cap of a bottle. So if we are opening the cap of a bottle, so we have to rotate like this, right? Rotate like this, then the cap will open means it will be upward. So n cap is the unit vector, upward unit vector, which is perpendicular to both a bar and b bar. Okay, but if you take the reverse order, b cross a like this, clockwise direction, if we take b cross a, then n cap will be downward direction. That you have to remember. Okay, this is also called right hand thumb rule. So is it clear? A bar cross b bar is modulus a bar is a, modulus b bar is b, then sine theta what? N cap. Okay, suppose if we take magnitude of a bar cross b bar, then it will be a b sine theta, and magnitude of n cap, since n cap is unit vector, so its magnitude is what? 1. So this is another formula. Modulus of a bar cross b bar is a b sine theta. Okay, now let us try to understand or we can understand the geometrical representation of this cross product also. So as I write here, a bar cross b bar is how much? Modulus a bar means a b sine theta n cap. Okay, so a, then b sine theta, or you can take this line also, no problem. This line, see, a into then b sine theta. So a is the magnitude of this particular line OA, and what is b sine theta? B sine theta is the height of the parallelogram. Okay, height of this particular. So length into height is nothing but area of the parallelogram OACP. Okay, so this is nothing but what? Area of parallelogram. Now coming to the properties of vector cross product. Like dot product, cross product is not commutative. Why? A bar cross b bar and b bar cross a bar, there is one negative sign. So let us understand from the definition what I told here about the right hand thumb rule. If we find a cross b, right, if we find a cross b, then we will get n cap. But if we find b cross a, b bar cross a bar, which way we have to go? B cross a like this, then n cap will be in downward direction. So what we will get? Modulus b bar, modulus a bar, sine theta, and then what? Minus n cap. So here you have plus n cap, here you have minus n cap. That's why a cross b is not equal to b cross a due to one extra negative sign. So a cross b will be equals to minus b cross a. Dot product is not commutative. Then distributive property, these are simple. A cross b bar plus c bar, you can write a cross b plus a cross c. Okay, these are simple. Now this is one more important thing. If A bar and B bar are parallel, in scalar product we learn that if A, B are perpendicular, A bar is perpendicular to B bar, then dot product is 0. But here if they are parallel, then what will happen? Suppose they are parallel, A bar and B bar are parallel. So parallel means angle equals to how much? 0, sin theta 0, 0 or 180 degree. So in cross product what will come? Modulus A bar, modulus B bar, sin theta. In place of theta, if you put 0 or 180 degree, it will become 0. So for parallel vector, cross product is 0. For perpendicularity, dot product is 0. But if they are parallel, then cross product is 0. This is one more interesting property, property number 4. Same vector if you cross I, because the angle between them is what? 0. I cross I. So if we take same vector twice, then theta is 0 and sin 0 is 0. So that's why I cross I, J cross J, K cross K, they will all become 0. To find the cross product of different unit vector, we have to take the help of this particular cycle. Suppose I cap, J cap, and then what? K cap, anti-clockwise. So I cross J, you see, I cross J will be how much? K cap. J cross K will be what? I cap, the next one. K cross I is what? J cap. But if we take reverse order Ji like this, Ji, it is clockwise direction. So it will be minus K cap. Similarly, Kj, again reverse Kj is what? Minus I cap. So using this cycle, you can easily remember all these things. And then you can find the value of sin theta. So we have A bar cross B bar is nothing but modulus A bar, modulus B bar, sin theta, and then what? N cap. But if we take magnitude, then what will happen? This is modulus A bar, modulus B bar, sin theta, and this will become 1. Sin theta will become 1. So from this, if we want to find sin theta, it will get exactly this formula. But see, if two vectors are given, we have to find the angle between what? A bar and B bar. Is better you use scalar product formula, because here you have to find a little bit more. So that is easy. Okay. Now, how to find the cross product of two vectors where the components are given, like A bar. A bar is A1 I cap, A2 J cap, A3 K cap. B bar is also given. In dot product, A bar dot B bar is simply A1 B1, A2 B2, A3 B3. But here, cross product, we have to find like this determinant form. First row is I cap, J cap, K cap. Second row is the coefficient of A bar. Then third row is coefficient of B bar. So if you expand this particular determinant, you will get this particular value. So I think you all know how to break the determinant. So you can easily find it. Then area of parallelogram. Area of parallelogram is what? Half into A bar cross B bar. That I show in a physical interpretation of cross product. Then if we take 1/2, then it will be area of the area of rectangle like this. Area of triangle. If these vectors are suppose A bar and B bar, okay, then this area is modulus of A bar cross B bar. But if you want to find the area of the triangle, since this is B bar, this is also B bar. So if you want to find the area of this particular triangle, then just have to take half of the area of the parallelogram. Okay, so these are the properties. Now let us come to some problem. So it's a very simple one. A bar and B bar is given. We have to find the cross product, means A bar cross B bar. So A bar cross B bar. So how will find A bar cross B bar? Is determinant. First row is I cap, J cap, K cap. Second row will be 2. Then there is no J cap, 0, and then 1. Okay. Then coefficient of B bar 1, 1, 1. Now if we expand this, how will expand this? I cap into, I think you still remember this row, this column have to vanish, 0 minus 1, then minus J cap. Now this row, this column vanish, 2 minus 1, and finally K cap into what? This row, this column vanish, 2 minus 0. So if you calculate it, you will get minus I cap, then minus J cap, plus how much? 2 K cap. Okay, 2 K cap. So it's very simple. Now let us take second problem. Now what to do? We have to find the value of lambda and mu. See, what is the left hand side? Cross product of two vectors. So to find the cross product of two vectors, what will write? The first row is I cap, j cap, k cap. Second row will be 2, 6, and then 27. So when the numbers are a little bit big, you have to be a little bit cautious. 1, lambda, and then mu. What is the right hand side is 0 bar. Okay, our right hand side is 0 bar. So like the previous problem, I'll you just expand this particular determinant and find the value. That is, I'm not going to do here. So what we will get after expansion is 6 mu minus 27 lambda I cap, then minus twice mu minus 27 j cap, plus last one is this vanish 2 lambda minus 6 k cap. Now what is the right hand side? Right hand side is 0 bar. So 0 bar we can write 0 I cap plus 0 j cap plus 0 k cap. Now what to do? You have to just simply compare. So if you compare, better you compare this one and this one, because here you have both mu and lambda is involved. So if you compare this one with j cap, the coefficient of j cap is how much? 0. So what will write? Minus twice mu minus 27 is equals to what? 0. And then second one is, if you compare coefficient of k cap, 2 lambda minus 6, right side coefficient of k cap is how much? 0. So lambda is how much? Lambda is 3. And first minus you have to cancel. Mu equals to 27 by 2. Okay. So if you can do the calculation correctly, you see the problems are very, very easy. Okay. This is another problem. So for any vector a bar, we have to prove that modulus of a bar cross I cap whole square, similarly for j cap and k cap, is equals to what? 2 into modulus a bar whole square. So let us do it like this. Let a bar is equals to a1 I cap plus a2 j cap plus a3 k cap. Okay. So let us first find a bar cross I cap. So a bar cross I cap. So it's a1 I cap plus a2 j cap plus a3 k cap cross I cap. Okay. So I cap cross I cap is how much? 0, right? By using determinant also you can find, or directly also you can find. So I cap cross I cap is 0, so it will not come. 0. Then if you find this j cross I, so I made the cycle, right? J cross I, it's reverse order, so it will be how much? Minus, it will be our minus a2. Okay, minus a2. Minus a2 and then k cap. And then ki. After ki will come, so it is in a similar order, so it will be a3 j cap. Okay. Now if you take modulus magnitude of this, so if you take modulus, it will be root over a2 square plus a3 square, and then finally if you square it, a bar cross I cap whole square, root will vanish, a2 square plus a3 square. Now you just see I cap is there. For with I cap, what is the coefficient? A1. So here A1 is absent. So if you take j cap, then A2 will be absent. If you take k cap, then A3 will be absent. So similarly, other two you can easily write. Similarly, a bar cross j cap whole square. So what will get? A1 square plus A3 square. A2 will not come. And then a bar cross k cap whole square. Now it will be a1 square plus a2 square. Now what is the left hand side? So left hand side is a bar cross I cap whole square, a bar cross j cap whole square, a bar cross k cap whole square. So if you put all the values, no, what will get? If you put all the values, a2 square plus a3 square, then second one is a1 square plus a3 square plus a2, sorry, last one is a1 square plus a2 square. So it will be 2 into a1 square plus a2 square plus a3 square. So 2 into a1 square plus a2 square plus a3 square is nothing but modulus a bar square. So it's this is also very simple. Okay, now let us take problem number 4. So here what to do? What is given? Find a unit vector perpendicular to each of the vector a bar plus b bar and a bar minus b. A bar and b bar is given. So which vector is perpendicular to both a bar and b bar? Just remember this thing. If this is a bar, this is b bar, then the vector which is perpendicular to both a bar and b bar is nothing but a bar cross b bar. So here one vector is a plus b, another vector is a minus b. So first you have to find this a bar plus b bar, a bar plus b bar. So if we add a bar and b bar, what we will get? 2i cap, 3j cap plus 4k cap, and then a bar minus b bar. So it will be I minus I0, 2 minus 1, j cap, and then what? 2k cap. So what particular vector is perpendicular to both the vector? Let it be c bar. So c bar will be a bar plus b bar cross what? A bar minus b bar. Okay, so both the vector you already find. One is 2i cap plus 3j cap plus 4k cap. Second one is j cap, and then what? Minus 2k cap. Since it is a bar minus b bar, so our a bar minus b bar, what is a bar? This is a bar, no, I0, sorry, j minus 2j, it will be minus, then k minus 2, it will, this is also minus. Okay, so first one is 2i cap plus 3j cap plus 4k cap cross, second is minus j cap minus 2k cap. So again by using determinant you find the vector, the cross product you find. Finally you will get minus 2i cap plus 4j cap minus 2k cap. This one you will get. So as we already know how to find the cross product of two vector, so that part you do. So this is our c bar. So what to find? We have to find a unit vector along c bar. Means we have to find c cap. So it is nothing but c bar by modulus of c bar. So minus 2i cap plus 4j cap minus 2k cap divided by modulus of c bar is how much? 4 plus 16 plus 4. Okay, so finally the answer is 2i cap plus 4j cap minus 2k cap divided by how much? 2 root 6 is the answer. Okay, 2 root 6. So it's very simple. You can write like this. After dividing also you can write this by this is how much? Minus 1 by root 6 I cap plus 2 by root 6 j cap minus 1 by root 6 k cap. Okay, so this is one very interesting problem. Okay. Now let us come to problem number 5. A bar, b bar, c bar are given. Find a vector d bar which is perpendicular to d bar, which is perpendicular to both a bar and b bar. Also there is another condition, c dot d is how much? 1. So if a bar and b bar both are perpendicular to d bar, then what we can write? If both are perpendicular to d bar, then d bar must be like this. Okay, since d bar is perpendicular to some constant into a bar cross b bar. Okay, this constant, this particular constant value we have to find. So lambda into, so it will be I cap, j cap, k cap. Coefficient of d bar is what? 1, minus 1, 0, and it will be 0, 3, minus 1. Okay, 0, 3, minus 1. So lambda into, if we split this, what will get? I cap plus j cap plus 3 k cap. This will come. Now what is given? C bar dot d bar is equals to what? 1. This implies c bar. Is c bar is given? Yes. 7 I cap minus k cap dot d bar is lambda into I cap plus j cap plus 3 k cap is equals to what? 1. Now lambda is constant, you can write it outside. How to find the dot product is 7, j cap is not there, then minus 3 is equals to 1. So the value of lambda is how much? 1 by 4. Where you have to put this value? The value of lambda So therefore d bar equals to is how much? This is 1. Okay, not this one. So lambda means 1 by 4 into I cap plus j cap plus 3k cap. So this problem is also very easy. When you look at the question, if you know if a bar and b bar is perpendicular to d bar, then what to write? Then other part is very easy. Okay, now let us take today's last problem. A bar, b bar, c bar and d bar, 4 vertices of a quadrilateral is given. We have to find its area. So we know that suppose A, B, C, D. So I am drawing a quadrilateral, but a parallelogram type of shape, but it could be anything. So if you know AB bar and AD bar, two adjacent side, then area of quadrilateral is what? Area will be suppose half into AC bar means this diagonal. So this I didn't mention in the property, AC and BD. Okay, so like this also you can find the area of quadrilateral, AC bar cross BD bar. Okay, AC bar cross BD bar. So first we will find AC bar. So you all know how to find AC bar. Position vector of C minus position vector of A. Okay, so position vector of C is what? 22, 19, minus 5, and A is 0, 1, 1. So if you subtract, after subtracting, what you will get? 22 minus 0, so it's 22 I cap, minus 19 minus 1, so it's 18 j cap, and then minus 5 minus 1 is minus 6 k cap. So in the same way we will find BD bar. Okay, so BD bar. So what is BD bar? BD bar is position vector of D minus position vector of B. So after finding, you will get minus I cap minus 5 j cap plus 3k cap. Then what is the next step? We have to find AC bar cross BD bar by using the determinant. Okay, so use the determinant and find it. So you will get 24 I cap minus 60 j cap minus 92 k cap. Okay, you find and verify it, and then finally area will be half into modulus AC bar cross what? BD bar. Okay, BD bar. So half into, so you already find this one, so it's root over 24 square plus minus 60 square plus minus 92 square. So numbers are a little bit big, so but if we calculate, you will get half into 12640, this one. Okay, so if we can cancel it, if we take these two inside, then it will be 1260 by 4. So the final is 3160 square what? Unit. Okay, so I hope this cross product or vector product and their examples are very much clear to all of you, but you have to do some more problem. So from any book, kindly you do at least 20 problem, so that this portion is very much clear to you. Thank you for watching.